So factoring, is there a GCF? That should always be your first question. What do you think? No. And remember to look for x's or whatever variable as part of your GCF. Okay, a times c up here, which is 75. B is negative 20. And then a on the sides is 3. Are there factors of 75 that add up to negative 20?
Yes.
Okay, what are they?
Negative 15, negative 5.
Yep, good. Negative 15, negative 5. This side can be simplified to 1. Side is good. Okay, now we're ready to go write these in our factors. And we're done. For now, that's all we need to do. How'd that go? Any issues, any questions, sticky points? Alright. When I look at both of these, first of all it says solve, but I don't see a bx term. What does that tell us? In other words, like here's our ax squared, here's our c term, no bx term. So what does that tell us in terms of solving strategy? No bx term, solved by square rooting, right? Okay. So our steps said get x squared, or the variable, get that squared term by itself. So first I need to subtract 1. And then I need to get the 7 off of here. Now we can square root. And technically this is plus or minus 2. Most likely you just wrote 2, and in geometry, most often we use just the positive version. Not always, but mostly. But just know that, like, what does square root mean? You guys I didn't ask you that yesterday, do you remember?
Like, what multiplies by itself to create that?
Yeah, so what times itself gives 4? Well, 2 times 2 is 4, but also negative 2 times negative 2, right? That's why there's also that negative root. And if you're thinking about what this graph looks like, if we said y equals x squared minus 4, so thinking back to Algebra 1 where you learned the graph of a quadratic or a parabola, that phone needs to be turned on. It's shifted down 4. And remember when we're solving quadratics, we're looking for the intercepts, the x-intercepts. So where the function equals 0. Do you see why it was 2 and negative 2 both when we do it graphically? So we're looking for where that parabola crosses the x-axis, and in this case at 2 and at negative 2. So it's really both. Okay, same thing here. We're just going to subtract 10. And then divide by 2, and then we can square root to get m equals 10, plus or minus 10. Same thing. This one would just be shifted down 10 and cross at 10 and negative 10. Not shifted down 10, excuse me. It would be shifted down 100. How'd those go? Hold up how many you got right. 3, 2, 1, or hopefully no zeros. Okay. Well, that's doing pretty good overall. Let's check your homework. On page 1, we had to finish up these GCF problems. So what's a good GCF on number 2?
7.
And?
A.
7 and A, yeah. Okay, remember immediately pull that out front so you don't forget it. And then we can start dividing. So I told you yesterday to separate numbers from letters. This is 14 divided by 7, and then A divided by A, so that's just 2. Okay, 21 divided by 7 is 3. A squared divided by A is A. And then 21 divided by 7 again. A cubed divided by A is A squared. Okay, and then if it said completely factor, we would want to look at what's inside parentheses and see if we could star that. Okay? Are there factors of 6? Like this is backwards, but we would do A times C. So factors of 6 that add up to 3. Is there such a thing? No. So this one would not star factor. Alright, next one. Is there a GCF? Yeah, what is it?
4.
4. Pull it out front. We get 3r squared plus r minus 3. Okay, are there factors of negative 9 that add up to 1? No, because it's either 3 and 3 or 9 and 1. That's it, right? So that doesn't factor any further. Okay, next one. GCF. Is there one? Yep, 9 or negative 9. My suggestion, if you ever run into this where the squared term is negative, you should make it positive. So let's do negative 9x, just to get in that habit. Immediately write that out front, and then we'll get 1 from the 9s, and x squared over x is x. Over here, minus, and then x's cancel, and then we'll get minus 5. How's this going so far? Okay, GCF factoring is a really big deal because sometimes you have to do it, and sometimes it just makes your life a lot nicer. This one only has a letter. Is that okay? Yeah. Pull it out front, just like the numbers. Okay, 11 stays there because it didn't cancel with anything. Y squared over y is y, and then minus 8. Okay. We did the first two, so that was 4. Hold up, how many you got right out of those 4? Okay, so keeping in mind if you're at like 2 and 3, if this was a test, you would have just failed it. So learn from that and grow and ask for help if you need to, okay? 4 out of 6 is still a D. Sorry, we're doing out of just the 4. 3 out of 4 is a 75, so that's a C. 2 would be an F, and then 4 would be your A. So if you're looking at grading, of course just on these 4, just keep that in mind. Alright, page 5. I wanted to talk through some of these, so that's why we're taking time to do them. This one's ready to just square root rather. So 5 or plus or minus 5, since we're thinking about those negative roots. Okay, this one also ready to square root, and we get, here's how you write it when you leave the square root. Put the plus or minus out front. But we can simplify 12, the square root of 12. We can break 12 into the square root of 4 times the square root of 3. You'll put your pretty square rootable factor out front, and the non-square rootable factor next. And then just go ahead and square root the one that you separated out that's nice. So this would be square root, 2 square root of 3. That's called simplifying the radical. The check mark symbol is the radical. It's kind of a weird description of it, but that's called a radical. Write that down. In Algebra 2, we will do a lot with those, with other roots. So 5th root, 6th root, 7th root, 4th root, 3rd root. Okay? It's not going to just be square roots anymore in that Algebra 2 class. And we're going to connect that to what we call rational exponents. So you're going to see this and hear this word a lot. Alright, this one we left this way because you can't split 15 into anything square rootable, right? Like thinking factors of 15, in fact I'll write them out. We have 1 and 15, 2 doesn't work, 3 doesn't work, 3 works but isn't square rootable, I mean. 4, 5, 6, 7, all that, like none of it is square rootable. So leave it as square root of 15. Okay, next one, get that 8 over there to a 0, like subtract your 8, divide by 5, and square root. So what is the square root of 0?
0.
Do I need to put plus or minus? No. I didn't put that in here. Let me go ahead and do that real quick. Okay, next one, subtract 15. Divide by 5. Square root. What's this one going to be? Okay. So far so good? Alright, issues on F. What do you notice about F? Those of you who did it. And by the way, if you don't do your homework and then we go over it like this, you should do it on your own. So you get the practice, not the credit. Homework is for practice, not for credit. Okay, so trouble there. Why? Why?
Because it doesn't exist within these round numbers.
Is there a number times itself that gives a negative? No, because any time you do times itself, it becomes positive, right? Whether it's negative or positive, if you multiply it by itself, it's positive. So there is no such number that multiplies by itself and makes negative 3. Right? In Algebra 2, we're going to circumvent that issue and go into the imaginary number system, which sounds like I'm telling you a fairy tale, but it's real, like we actually do it. So for this one, there's no real solution. You cannot say no solution because there is one. It's just in the imaginary complex number system. But in the real system, it's not. There isn't one. Alright. I mainly wanted to address that one, but I think it was good to probably go over the rest of these as well. Okay, this time when we divide, we get x squared equals positive 3. So now we're back to okay again. And we can say x is positive or negative. Sometimes we say plus or minus root 3. So, those of you who did this, how'd it go? Solving by square rooting. Typically, it's less work than solving by factoring.
Summer snow real quick?
Yeah, she's right there.
Just wrote that summer.
Okay. Do you mind unlocking that so she can get back in? Thank you.
Go.
Alright. There were, let's see, A, B, C, D, E, F, G. There were 7. Hold up how many you got right on that. And don't, if you didn't do the whole thing on F, don't count that. Like, if you got down to square root of negative 3 or, okay. Alright, so those of you who did it, it's looking good. Those of you who didn't, I would recommend going back and taking time to think through it again on your own.
Me too.
Okay. So we have talked about solving by square rooting. Probably the more common way of solving is by factoring. And so now we have a bx term. And you can see those problems coming up on the next page. So some of you got there already, but we looked at them yesterday. There is a bx term now. It doesn't have to have a c term, but it can. It doesn't matter. We know how to factor now, mostly. So grab your notes, let's put an example in there.
Yeah, that's it.
I guess I'm just trying to think of where to put this, because you kind of need to know the concept behind the idea of solving this slightly. I don't know. Let's put the title and we'll get this started at least. Let's clarify, is a BX term. Okay, there is a BX term now. Again, there doesn't have to be a C, but there can be. And I just want to grab one that we know how to factor, so we make sure that part's not the issue. Let's do this one. So you have already factored this one. I still am going to walk through it just to show the process, but that part shouldn't be an issue. Okay, here's the thing. I don't want to put all this in the example, but you can write it if you feel like it would be helpful to you. So I'm going to write something and then erase it just to provide the background. Again, if you want to write it, obviously it's your notes, you can do that. So here's the idea behind solving, just as a quick reminder. I kind of showed you in the warm-up. So you've seen it now, but let's a little bit more formalize it. So solving a quadratic is all about finding the zeros. Zeros. Is that one an E? No. Okay. I'll put this in a second, but what we mean by zeros is where the whole function equals 0. The y value is 0. So finding the zeros means where does it cross the x-axis? I said that in the warm-up. So if you need that clarification where y equals 0, that's what we call zeros. Okay, we're getting into a little bit of the algebra, and so that's why this is going to be brief. We'll cover it again back in Algebra 2. But this explains the first step, which is if we are solving in geometry, we might have a, let's say we have a quadratic setup. Maybe it looks like this. Okay? Maybe it comes from, and I've shown you this before, but maybe it comes from like, let's do a different one. Something like this, 3x, 4x squared plus 7. We're going to learn that these angles are the same, like they're the same size, so we would set them equal. Okay, this is geometry. Remember, I'm trying to kind of weave algebra into it so you have a better go of next semester. But we set them equal, but that is not what we're solving in quadratics. We are solving for the zeros. So what do you think we should do as a first step, even though our geometry problems set the equation up this way? If I want to know where the function or where the y value is 0, what should I do with this first? Okay? We need to get it equal to 0. Okay? Again, the process, the method behind solving a quadratic by factoring is finding the zeros. So if I'm given one like this in geometry, I don't solve it like that. It's not a linear equation. I need to get it set equal to 0 so it's back to quadratic solving. That's the theory behind what we're about to write. It will be very helpful if you think of that and don't just follow my steps blindly. Okay? Everybody clear? Okay. I will post this if you didn't write it and want to. If you change your mind, you can go back and do that. So, step 1. Get the equation equal to 0. So in this case, I think, let's do it this way. Please, to just edit your example so that you can see this step in action. Just put in equals 40 to start. And it'll come back to what we just saw, but this illustrates the step, okay? So in geometry, we start with some wonky equations because of the relationships involved. We have to fix them to where they're solvable. So get the equation equal to 0. What do you do to do that in this case?
Substitute x for 0.
No, we just want this whole thing to be equal to 0, so we just subtract 40 from both sides. Okay? So this becomes 2x squared minus 2x minus 40 equals 0. Okay? In the example down below, now that you know what I'm saying, how would you get this equal to 0? Subtract 3x. And go put it in the middle, right? I'll write that just so you can see it. So 4x squared minus 3x plus 7 equals 0. You do still want to write it in standard form, like write the 3x where it goes. Okay? So set it equal to 0. Algebraically move stuff around so that it equals 0. That's what we mean by that. Step 2. Well, we are about to embark on a factoring journey, so what should we do first? Yeah. GCF, right? If there is one, pull it out. Is there one here? Excuse me, yeah. Write it out front. Okay, step 3, star. Star, do we star the GCF or just the inside? Just what's inside. Okay? So we're going to do a little mini star here. And we're going to get negative 20, negative 1, 1. Are there factors in negative 20 that add up to negative 1? One of them has to be negative. You're right about the numbers. Negative 5. Okay? So no reducing, like don't have to simplify the sides. These are both ready to go. So our star gives us this. Now, here's the difference. This equals to 0 is still here. You have to bring it down. Okay. Do you remember the zero product property from Algebra 1? Okay. It's a big name for, I hope, a simple concept. Here's what the zero product property says. So everybody look here because I'm going to point. Do you see that this is 2 times something on the left side? Okay? And it all has to equal 0. So if I'm multiplying and getting 0, something has to be 0. in the multiplication. Do you agree? Yes? Okay, if it doesn't work for you, let's do like 2 times smiley face times frowny face. You don't have to write this, we're just thinking theory. Equals 0. The only way to multiply and get 0 is if one of those is 0. Or maybe all of them, or 2 of them, or whatever, right? That's the zero product property. If I have a 0 product, something is 0. Well, can this 2 be 0? No, that doesn't work. So it's either of those two things that are the 0, right? Back to the idea of what we're solving for, it's those two that are making this thing 0, okay? That's the zero product property. So what that means is that we set these two equal to 0 and solve for what value of x makes them 0. You guys have done this, right? In Algebra 1. So our third step, this is the solving step. So far we haven't actually solved. Set the factors, excuse me, factors equal to 0. And solve each for x. I'll let you write that and then we'll do it. Set the factors equal to 0 and solve for x. Does 2 equal 0? No. So that's not gonna, we're not going to deal with that one. I usually have students kind of put a little squiggly just to separate these two. And we're going to say x minus 5 equals 0, x plus 4 equals 0. Now just solve those. Those are like the little easiest equations you've ever solved in your life. So what does this one give? What makes, like, solve that? What value of x makes that 0?
0.
Like add the 5, right? And x equals 5. How about over here? How do you get x by itself? So what is x? Negative 4. Okay? And then I'm going to write here just as for this particular example, 2 can't equal 0, so ignore it. Okay, here's our two answers. Those are our solutions. Our zeros, it has a lot of names. Roots, zeros, solutions, x-intercepts, all those things. Okay, now because this is a geometry class, your last step is to check if the solution works in geometry. Here's what I mean. If this was in a problem where we were solving for lengths, which of those would you kick out and say that doesn't make sense? Negative 4, right? Because you can't have a negative length. So then you would only have one answer in the geometry problem, even though in the algebra problem there were two. This is a pretty typical process. Set it equal to 0. GCF, a lot of times you won't have one. Star factor, set the two factors equal to 0, and there's your two answers. And you will get very comfortable and used to this. I know this maybe seems like a lot, but it's not actually too bad. Okay? Questions on the method? Let me have you try one. This is, by the way, if you notice, I'm zoomed in a lot, but this is the last thing before we actually do geometry. So, yay. We'll be able to do that tomorrow. Okay, actually let's use our warm-up just to illustrate. Everybody, if you have your warm-up handy, grab it and let's look at it. So I gave you one to factor. What would be our first step if I said solve for the zeros? What's step one on your notes? Says what? Set equal to 0. So step one would be 3x squared minus 20x plus 25 equals 0. Stick a 0 at the end. Okay, step two. GCF? No. Step three was star. So we starred all this, and we got x minus 5 times 3x minus 5 equals 0. Okay, step four. Sorry, flipping around a lot. Step four says to do what? Solve, like separate them and solve where they equal 0. So x minus 5 equals 0. Because remember, if that's 0, 0 times this is 0, right? 0 product property. Yeah, or the other side maybe. Okay, what is this x value on the left? X equals 5. How about this side? You might have to do another step here, but go ahead, it's okay. So add 5. And by the way, you're going to get to where you can look at this and just tell me what it is. You're not going to have to do the steps. Okay, now what? How do we solve that? Okay. So we have two answers. 5 and 5/3. Now both of those in geometry might work. Okay? Since they're both positive. But we're just saying, hey, if I plug 5/3 right here, I get 0, and that makes the whole thing 0. If I plug 5 right here, I get 0, and that makes the whole thing 0. That's what we just did. Do you see that? What's 5 minus 5? 0. What's 0 times whatever this is? 0. Okay, 5/3 times 3 is 5. 5 minus 5 is 0. If this is 0, it's all 0. Cool, right? Quadratic solving is kind of neat, honestly, if you understand what's going on behind the scenes. Any questions on it? Okay. Let me show you what we just did. No, that's not it. And can someone on the one that was the warm-up, will you please give me just a second here. Tell me what the equation was. It was 3x squared something something.
Minus 20x plus 25.
Okay. Okay, so look. Do you see this parabola crossing the x-axis 2 times? That one is 5/3. And that one is our 5. So there's our two answers that we found where it equals 0. Just so you can see it graphically. So on the last, I think it's page 6, right? I'm gonna go find it. Page 6. This page, whatever page, I think it's 6. Why don't you start working through those? Again, you don't have to have a C term to factor. But notice all of these are set equal to 0 to start off. So you're good to go until you get down there a ways. Now you know why. So if you notice these first 3, actually first several, I don't know how many because I can't see, but they don't have a C term, right? And it's an advantage when you are missing a term. We already saw that. If we're missing bx, we can just square root, which is faster than this. If we're missing c, we also have a shortcut, if you remember to do it, and for some reason it seems like people don't. I do want to talk through both ways that I'm seeing and point out, hopefully you'll see a better method. So a lot of people are doing star, where a times c is 1 times 0, because there's no c term. And then b is 4, and a is 1. And so we're looking, it's kind of a weird thought process to say factors of 0 that add up to 4, but that's what we're asking. And so a lot of you came up with 0 and 4. And then we get 1x plus 0, let's go over here. X plus 0 and x plus 4. Okay, please remember to keep this equal to 0 when you're solving, because we started by factoring just to learn that process, but we really did it so that we could solve. So make sure it's equal to 0. If I set this one equal to 0, it's just x equals 0. Are we good on that? Did I need to write the plus 0? No. And then of course this one, x plus 4 equals 0, is just going to give negative 4. Okay, that's one way to do this. I want to show you how that breaks down here. Okay, so if we set up the star, again, c is 0, so 3 times 0 is 0. b is 10, a is 3. And then same weird question, are there factors of 0 that add up to 10? That's 0 and 10. And if you look at our factors here, we get 3x plus 0, which this time I'm just going to write as 3x, because that 0 doesn't need to be there. So 3x times 3x plus 10. Does everybody agree this comes from this? Do you see a problem with it? Yeah, check this out. Like if we solve this, we're going to get the right answers in terms of solution. But if we redistribute, we get 9x squared plus 30x, which is 3 times bigger than what we started with. So it's incorrectly factored. Can you tell me why?
You didn't plus the 0 to the 3x.
No, that doesn't matter. Good thought though, because sometimes that does matter. Not the 0, but another number. What did we not, remember, what do we start off with when we star? Every time. GCF. There is a GCF here, isn't there? And we didn't pull it out, which made our factoring 3 times too big. Okay, so always start with a GCF. Anytime your brain says star, think, oh, I got a GCF first. What is the GCF here? Okay, and if we write this out, we get x times 3x plus 10. Now, if we do the star, I mean, if you look at this, you're like, why do I even need to do the star? Hopefully you're seeing that. Why? Isn't it already factored?
Yeah.
Like there's nothing else to factor, right? And so now we set each factor equal to 0, and this one just becomes x equals 0. Well, I just set it equal to 0. And this one, 3x plus 10 equals 0. So then we subtract the 10 and divide by the 3 to get those two. Okay? So be careful. Star works, but you still have to follow the procedure, which is GCF first. And on all of these, if you GCF first, then you realize you don't actually have to star anything. And it's kind of nice.
So you're pulling up the x for GCF, but couldn't you do that same thing for a?
Yes, you could. We could have absolutely done that here. So the best way to do this one is to write this as x times x plus 4. And then we get x equals 0 and x equals negative 4. Do you see how much faster that is?
Right.
Okay? Same, let's just go run through and do the GCF method on all these. Summer, are you with me?
Yeah.
Okay, what's the GCF here? Let's pull out a negative x, because then it makes the rest of it easier, I think. So negative x, and then this leaves us with x plus 5. What is this 0? The answer. What's the solution from that factor? Yeah. Set it equal to 0, and you get x equals 0. Set this one equal to 0, and you get x equals negative 5. Nice, right? If there's no C term, GCF will, like if you follow the star process, your first step is GCF and then you're done with these. Okay, GCF here, negative 2x. And we'll get x and minus 3. This one is 0. This one is 3. How you doing on this so far? Okay, now we have 3 terms. We do have a C term, so we should do the star at this point. And we're going to get A times C is 10, B is negative 7, A is 1. What factors of 10 add up to negative 7? Negative 5 and negative 2. So these become x minus 5 times x minus 2. And then has anybody noticed that there's a sign switch because you're moving it to the other side, right? So what do these become? X equals 5 and x equals 2. Now, I have had students in the past that do a couple things. They'll stop and not solve, and they think this is the solution. That is not the solution. That is the factor job, right? You do need to take it that one step further. And then here's a more common mistake. I hope you're listening. They will say x equals negative 5 and x equals negative 2. Why is that wrong? If I plug negative 5 here, do I get 0 for this term? No, it's negative 10. It doesn't make it go to 0. Negative 10. So, here's what I'm going to tell you. If it's not just clicking immediately that this is the solution to this side is 5 and that side is 2, write it out, please. Don't do all this work and then screw up at the end because you didn't finish. Right? X minus 2 equals 0. Solve that, you get 2. So write it out, write it out. It's definitely worth it. Alright, next one. You should have gotten x, what is this? Negative 8 and x equals negative 4, I believe. Okay, this one is not set equal to 0, so what's step 1? Yeah, subtract 2 over. Remember I said algebraically move things around? And then what else do you need to check for in this one? Yep. Okay. The 2 can't be equal to 0, so you don't worry about it. If you star factor this, your factors become x minus 12 and x plus 3. And then what happens to the 12? It becomes positive 12. What happens to the 3?
Negative.
You guys picked this up really fast, didn't you? You feel pretty good about it today? Okay, and then this one, your factor job is x. We have to set it equal to 0. I better show that. Alright, and then notice this is going to be negative 6 and positive 1. So, how'd you do overall? Let's do a fist of 5 if I gave you a quiz on this tomorrow. Alright, awesome. Okay, so let me give you the plan really fast. Tomorrow we're going to probably do a warm-up check on this, and then we're going to get into geometry. Yes, finally. Thursday, NWEA. So plan on bringing your calculator, your computer charged up and ready to go on Thursday.